The search for the ideal implant design. We have a variety of designs that we'll be talking about with a variety of platforms. Again, some of them are launched to provide the users of Nobel and Straumann and Zimmer with compatible products. Some of them are unique products for specific clinical applications. The two newest implants are the Swish Plus implant and a new one that has not yet been launched called the Interactive that has a Nobel Active compatible platform. It's basically the body of our Legacy 2 implant, which has been on the market for 3 years, but we added micro grooves and switched out from the 45 degree to a 78 degree lead-in bevel. It also has unique packaging, which I'll talk about. So there are a variety of screw implants. You have the Nobel Replace without a self-tapping groove. You have our Replant, which has the same outside profile, so it could be inserted with Nobel Replace drills, but we've added the self-tapping groove and micro threads. You have the Nobel Active, a more aggressive screw implant. The threads are deeper, but they're wider apart, so you don't really add more surface area. Has a sharp apical end that can get off track as you're screwing the implant in or tear the sinus membrane if it encroaches there. It has micro grooves compared to micro threads, which can add to stability. It tapers in at the top, which could potentially leave a gap at the crest of the ridge. When Nobel launched the Nobel Active, I came out with Reactive. I kept the Tri-Low platform. I didn't think that the Nobel customers needed to switch a platform just to get deeper threads. We made flat-based threads similar to a Straumann implant. The outside tapers at 1.5 degrees, depending on the length, 1 to 1.5 degrees, just like the Legacy 1 implant, just like the screw vent, but the inside threads taper at 3 degrees, giving you more thread engagement apically. Longer self-tapping groove halfway up the implant. Then the Interactive implant has 3 cutting grooves that go 2/3 the way up, just like the Legacy 2 implant that's been available from Implant Direct. Micro threads, and then we added micro grooves at the top. All of our implants have rounded apexes, just like the Nobel Replace. Micro threads, let me explain the advantage of that. We go from double lead threads, that's 2 threads starting at 180 degrees and wrapping around, so when you turn the implant, it'll drop twice as fast as normal threads would into the site. Then you merge with quadruple lead threads, and if you go from 2 to 4 threads, every other micro thread lines up with a pre-tapped thread in the bone created by the lead threads. And the alternate thread hits the crest of the bone thread that's there and cuts a new thread, adding stability. This animation will demonstrate that. So it's double lead threads at the bottom, represented by blue and red as it spins around. They look like the threads are 0.6 of a millimeter apart, but they're really 1.2. When you get into the neck area, the top 2.5 millimeters, it goes to 4 threads starting every 90 degrees. This is a screw plant with an external bevel and a long internal hex. I received a patent on the microthreads, even though Astra has a patent on microthreads, but theirs goes from single lead to triple lead, which means they need to be made shallower to avoid cross-threading. When you go from double to quadruple, you can maintain the microthreads at half the depth of the body, so they still provide some additional stability. Talking about different implant designs, we have the Nobel Active, which they recommend for experienced users. That's a euphemism for the darn thing may not work unless you're very good or very lucky. You really want implants that are simply easier to use and easier to use for dentists just getting started. Two features of this implant that I take issue with: the cutting groove is facing counterclockwise. It's to help you to unscrew the implant when it gets jammed in the dense bone, and that it does that if you try to insert it into dense bone, because it flares so dramatically. And the apical end is very sharp, which can allow the implant to track in a different direction as you're screwing it in, or tear the sinus membrane. So when you compare this to the reactive implant, which has the trilobe that comes on a fixture mount that's a preparable abutment, you can see the advantage. This also has platform shifting. Here's close-ups of the Nobel active implant versus the reactive body, which is the same as the Legacy 3. This is the Legacy 3 because you can see the internal hex, a nice clean anodized internal hex. Compare that to the Nobel internal hex, and you can see burrs left on the implant from manufacturing. So high prices do not necessarily assure high quality. Comparison of the apical ends. Here is the Nobel active with its sharp ends, its reverse cutting groove, very wide and deep threads. The Nobel replace, where the threads blunt down to next to nothing and don't have a self-tapping groove. A standard V thread, 0.6 of a millimeter apart on the pitch. Double lead threads means that every other thread is contiguous. Cutting groove, that's on the Replus, the Replant, the Legacy 1 implants, and all the Spectra system implants. And then you have the reactive and the Legacy 3 implants and the Swish plant that have these threads that get progressively deeper, increasing the surface area. Now, the greater the flare, the greater you're going to be compressing the bone, you think. But actually what happens is when you have real deep threads, the bone can squish into those, so you don't get as high a stability with a real deep thread as you do with one that is a little shallower, and I'll show you that in a chart shortly. So here's the difference between the reactive, where the outside tapers at 1.5, the inside at 3.5, versus the Nobel active, which flares dramatically and then comes back. Here is a chart off of Zimmer's website where they compared initial stability. The tapered screw vent generated 119.9 Newton centimeters of torque to insert it into the bone model they were using. The Nobel active was at 93 and the Nobel replace was at 89.5. No significant difference here, yet one has very deep threads. And is marketed as increasing stability, but it doesn't take much more force to screw it in than the Nobel replace. The Straumann, which was tested, was half the stability of the tapered screw vent, only 60 Newton centimeters. So design does affect initial stability, which does affect clinical success and your ability to do immediate loading. Here's the Legacy implant with its rounded end, used as what we call an internal sinus elevation. You drill through the floor of the sinus, push bone graft material up, tenting up the membrane, and screw the implant in. Nice round end there. And these are Nobel active implants. And you can see the sharp pointed ends near the floor of the sinus that would not be advisable in a procedure like that. You also see the tapered neck, which can leave a gap. This is from Nobel's literature. It says Nobel Active is a unique implant system. It offers experienced surgical restorative clinicians an enhanced set of options for cases involving soft and medium bone. So they're telling you don't use it in dense bone. You don't know what the density of bone is often until you get into it, so it's a little late to be ordering your implant then.